Can one of you guys confirm that you guys able to hear? Okay, cool. Thanks. Um, so yesterday we discussed about, let's recap quickly for a couple of minutes. So we talked about different type of variables, right? Like different type of mm, all we're trying to learn now, right? In the core Java, in the beginning, what we're trying to learn is what and all these variables are, what and all these keywords mean to us. Like these are all keywords that we have, right? So we're trying to understand each and every keyword purpose by doing some understanding the inner concept behind giving this keyword and how to use it and try to implement it. So that's what we're trying to do. We learned about public. Public is something what you can apply for any class level, method level or variable levels, but you cannot apply to local variables. You can apply to class variables, you can apply to methods, local methods, you can apply to classes. Same thing for protected. So these kind of definitions we started learning. So there are a few more we need to learn before we go there. Yeah. So what will happen? What will happen when you use one of the modifiers that we mentioned here to the variables or methods or method variables or classes? What, whether they can be accessed, they can be allowed or not. This chart will give you whether they are allowed or not, right? So this one, this what is this chart tells about? Like, it's kind of provides us mm, what will happen when you use these variables, these modifiers, and if you try to access across the different classes and across the different packages. So we know the scopes here. These are the scopes, what will happen kind of thing. Okay. So and we even talked about what you called we even talked about inheritance concept, right? What is inheritance? Inheritance is something you use it for code reusability, and we can, if you want to, if you don't, if there is a functionality available in different class, and if you want to access those functionality in your class, you need to go for inheritance concept. So inheritance also certain rules. What are those rules? Like where is that? Yeah, there are different type of inheritance we have, like simple inheritance, multi-level inheritance, and multi hierarchical inheritance, and multiple inheritance, hybrid inheritance. So in these four, basically simple inheritance, these are the four concepts, five concepts that has been there in object-oriented concepts. Among those object-oriented concepts, Java adapted simple inheritance. And how can you inherit? How can you inherit something from one class to another? Using the keyword called extends. So what you can inheritance? All the behavior that the parent class is having. What does it mean by? So all the variables that as parent class is having, all the methods that the parent class is having, right? Then multi-level inheritance. What is multi-level inheritance? This is like, class A extended by B class B extended by class C. But hierarchical inheritance, same class extended by two different classes. Multiple inheritance is not allowed, but you can achieve through interface. I will discuss about interface concept. And about hybrid inheritance. Hybrid inheritance also not allowed, because after extends keyword, you can extend only one class. That's what you need to remember. Okay. So and we tried a program called symbol inheritance here, right? So I hope you guys tried for different inheritance and saw what will happen. So you guys need to try different things, like, what if I keep private here? What if I give private to this variable? Can I able to access here in class B? Can I able to access here, like, as well as what it says? No, it cannot be, because the moment you give private to any variables, any members of a class, then the scope will be died within that class. As simple as that. Even whatever you do, whether you by creating an object or by trying to access, by trying to extend, you can't access at all. Okay, make sense? um, and another one is, let's say if you try to create a class object and try to access it. What it is saying, it cannot, like, it cannot able to understand, it cannot able to identify. Make sense? So you cannot access a private variables. Those concepts, those experiments, you need to try and have to remember the logics behind it, concepts behind it. Okay, so next concept is, so as we know, multi-level inheritance is not allowed, which means extending two classes is not allowed. But like I mentioned, we can achieve through interface. How can we achieve? So there is an interface concept. Before going to interface, can we discuss about abstract class? That would be easy for you to understand interface. Let me see, if I can write a simple abstract concept, and then, or else before going to um, abstract class, can we do some, what you called, give me a second, I'm just verifying which way is the better way, like, rather than constructor concepts. It's better to discuss the constructor concepts. Yeah. So what and all we need to discuss is interfaces, interface and constructors and abstract class, memory allocation. If we complete these four, we can go out from the basic concepts. So when we talk, and then here we can get, like, method overloading versus method overriding. What else the concepts that we need to discuss? Let me see if there is something. Yeah, strings are there. As we planned, it takes 14 to 15 days of core Java finish, right? So yeah, string and method overloading, then threads, collections, IO. Yeah, let's see what happens. Generics. Yeah. So let's focus on one by one. So before, let's start with constructors. So constructor, what is constructor, right? As of now we are already using constructor, but we just don't know what is constructor. So basically, what constructor is something, how can I say clearly? Simple word, simple way of explaining is, yeah, we can say constructor is something is a method. Basically, constructor is what is constructor? Constructor is a method, but it's a special kind of method. It's a special kind of method which the method name will be the same as class name. Then we can call it as a constructor. You got my point? So constructor is a special method whose name is same as class name. See, now can we say main as a constructor? No, because it is a method, but it is not with the same name as class name. If any method, if it is same as class name, then we can call it as a constructor. So let's say, so method A is not constructor. Method A is a method, simple method, right? So how can I, and then there are certain rules. One rule is it should be a method with same name as class name. And another rule is constructor should not contain any return type. There is no concept of return type, but generally when we say method, the few things that comes into your mind is method name and return type will be there. It takes as many as inputs that we want, right? But in terms of constructor, it's a method with the class name, and constructor doesn't contain any return type, okay? Because it doesn't return anything, it just creates an object. Constructor uses, okay? Constructor will be invoked by JVM, okay? Constructor will be invoked by JVM when we are creating the object. When we are creating an object, when we try to create an object, constructor will be triggered by JVM, okay? Constructors are used to initialize the object with some values. So if you look at here, right, this is called constructor. This is constructor accessing. This is constructor accessing. Whose constructor it is? B class constructor. It's a constructor of B class. Make sense? So let me repeat the few rules. Constructor is same as class name. So, and it same as class name, and it is a method, special kind of method, same as class name, and it doesn't have any return type. So now you can call it as, this is the definition of constructor. You can write whatever the logic you want, okay? System.out.println inside constructor. You cannot call this guy. Now if you look at here, so this is where we know that execution, everything happens, right? So what we did in this main method, we created a B class constructor and we called A class method, a method in A class. How can we able to call A class method from B class object? Because of inheritance concept that has been there, right? But so we created a B class object and it called a method in A class. So it should display only inside method A. But if you look at the output, it displayed first inside constructor, then inside method A. Who called this inside constructor? Who called this inside constructor? This is called by whenever you write this, right? Whenever you write something here, the B constructor, this is triggered. This constructor inside B constructor, A constructor is triggered. So let me show you simple way, like constructor example. I need a demo. So in this, what I will do, another class I'm writing, class car. Okay, so inside what I will do, I'll have a default method, simple method. What it will do, I mean, I'm writing system.print system.out.println because we can see the output. We can write as whatever the logic that we want inside. Okay, so inside car method. Okay, another one is you need to have a constructor, right? Inside car constructor. So here what I will do, I'll create a car object. Car object, you can call it as whatever it is. Object name should start with small letter. Okay, reference variables always should start with small letters. See, I'm not calling this method. Okay, I'm not calling this method. Let me run. I just created an object. Okay, let me run. What will happen when I run this? I haven't called method or anything, right? I haven't even called the constructor. I haven't even called the constructor explicitly, but it triggered inside car constructor has been triggered because in the process of creating an object, a constructor will get called. First thing happens. Okay, a constructor will get called. Let's see another logic. I'm just mixing couple of logics so that you can see the differences and you can apply logics as well. Okay, see, if this is the static, we know static block, right? I'll write here another one. Which one get called first? Inside static block, and then constructor. Let me call the method. Okay, call obj dot this is the method, right? So this is how we need to call. I never mentioned, but this is how you need to call dot of something when you create an object, and then when you use dot is something that we can use it to access the variables, access the members inside that object. Okay, so now let's run the program again. Now you got three blocks inside the static block, inside car constructor, inside car method. So what we understand from this, so first thing is class loads into memory. When class is loading into the memory, it looks for all the static members like static block, static variables, static methods. It loads them. So here static block is there, it loads the static block, and then if you ask for a constructor creation, if you ask for if you are trying to create a car object, then it triggers immediately car constructor, the one that you wrote. If you don't write, what will happen? The default constructor JVM will create automatically for you inside. If you don't write this constructor, right, this is the constructor. What it is doing is just printing inside car constructor. If you don't do this, what will happen? It will create default constructor inside. It will create a default constructor inside when it is running, right? When it is loading, okay, it looks for, is there any default constructor that they wrote? If there is no default constructor, then JVM will generate the default constructor and execute the program. Okay, so there are few more rules around that, like Mm, so another rule is when we write a class without any constructor, JVM inserts the default constructor. When we write a class with an argument constructor, JVM doesn't insert default constructor. We have to write the default constructor explicitly. Okay, so let's understand few more things in the constructor concept. Okay, so if I don't mention any constructor, okay, in this class now there is no constructor at all. If there is no constructor, what will happen? Default constructor will be inserted with a Java virtual machine JVM. Okay, good. What if I mentioned the constructor default? What if I mentioned the default constructor? What is the default constructor? Default constructor is a constructor without any input parameters, then it is called as without any input parameters. This is called a default constructor. Okay, and let me write another one. Okay, so if you write 2 right, then it will show an error, you have a duplicate. So what you need, if you want to, why do you, if there is another option that you can create a argument constructor, as many arguments as you want, along with the default constructor. So let's say I'll say int a, and I can create another one called, another default constructor called string. I can create another one called string a int b. So 2 arguments constructor. This is 1 argument string constructor. One argument int constructor. So what is the difference between these 4 constructors? First thing is they are all constructors because they are going with the class name, right? But what is the difference? This is the default constructor. Default constructor is something which doesn't have any input arguments, and this is a constructor with int as an input argument, and this is a constructor which is as a string as an input argument. This is a constructor which is 2 values or 2 arguments constructor with string and int, right? So now let's see what will happen here. Which one will get called when you call like this? Default constructor get called. Okay, so let's say if I remove this guy, right, what will happen? You got an error. Why? We tried some time back when without mentioning we had a definition called if you don't write any default constructor, then JVM will insert a default constructor. That is a definition we just discussed, right? Then why I didn't mention the default constructor, but when I try to run this time I'm getting error because there is another rule. When you write a class with argument constructors, so you wrote a class with arguments constructor, these are all argument constructors, then JVM doesn't insert default constructor. JVM doesn't insert default constructor at all. We have to write the default constructor explicitly. Remember that. Okay, so for this case you need to write default constructor explicitly. Okay, so let's say, so when you run this program, you are able to see default constructor. What if you want to call one argument constructor? What do you need to do? When you are creating an object, you need to pass some integer. So if you pass him some integer, it will instead of triggering this guy, it will trigger this guy. Make sense? So what if you want to trigger this guy, this two arguments constructor? All you need to do is go back and pass string and number. Then if you run, it triggers two argument constructor. Make sense? So these are the constructor concepts around. Okay, try to understand. Okay, see, go back and look around what is these constructors and how this works, kind of thing. So good, we did finished quickly. There is one interesting concept here in learning these constructors. So let me explain you before I jump into something else. Let me keep only two so that I can get some space so that you guys can see everything. What I'm going to do is here I'm going to write another class called class BMW extends car. Okay, here what I will do, I'm going to create BMW constructor, default constructor. Okay, BMW default constructor. Okay, another one, what we can do, I will write another BMW single argument constructor. Okay, I have one argument BMW, one argument inside constructor. Okay, car one argument. So now what I did, I created a class called car and I created another class called BMW, and I extended the car behavior into my BMW. Now what I will do here, I'll create a BMW object. Okay, BMW object. Let's see what you guys trying to understand, whether you guys understand or not. So now I just called BMW creating an object. So which one will get called? Default constructor of BMW it called. So what is the output that we can expect? I am BMW default constructor. This is the only line that we are expecting, right? Let's see what happens. What is the result? So let's remove this static block. We are done with the static block. So if I run this program, instead of seeing I am BMW default constructor, you are also seeing along with the I am default BMW default constructor, along with that we are seeing default constructor as well. Where is this default constructor? It is in the car. It is in the car class. Then how come when I call BMW constructor, it called the car constructor? Because there is a concept called super. There is a concept called super. What it does, if you extend something and if you have a default constructor, if you have any constructor, then there will be immediate in the constructor by default this list line will be added, super. Even if you don't write it, JVM will insert this super. What does it mean? When the program compiles, right, so this super will be inserted here. So what it happens is, it before executing this line, it will call its superclass constructor. It will call its superclass constructor. Who is BMW superclass? Car is the BMW superclass constructor. So it will go to superclass constructor. First it calls this constructor and executes this constructor and then comes back and executes the remaining lines inside the constructor. That is the concept of super. Same thing applies for single argument constructor as well. If you try to if you try to call some number, then what will happen? It will first, if it will first, it will first add default super constructor. Okay, it will go to default constructor. So what is the default constructor here again? This one. But what if you want to call this guy? When you call single argument constructor, when you call single argument constructor in BMW, what if you want single argument car constructor? So in that case, you need to write explicitly. You need to write explicitly. Then it will get executed. Car one argument constructor, BMW one argument constructor. Otherwise, default value has been, if you don't write anything, default super will be inserted across all the constructors. That is another concept, remember, okay? So super is, what is super? Super is something which we use to invoke immediate superclass constructors, okay? So with inheritance, constructors will be invoked from bottom to top. What is the sequence here? Bottom to top. First, the invocation will be bottom to top, but constructors will be executed from top to bottom. First it will, when you try to, invocation is nothing but when you try to call this guy, if you click on this will be invoked. From here, before executing this line, default super is inserted, so it will go to car constructor. So invocation is bottom to top, but constructor will be executed from top to bottom, because we see the first result as car constructor and then BMW constructor. And super is the first line in any constructor. Okay, when you are not writing any super in the constructor, default super will be inserted by the JVM. When you write any super, JVM doesn't insert any additional super constructor. Only one super will be allowed. Only one super will be allowed. You cannot write multiple super constructors. Make sense? So, yep, we done with super concept as well. Constructor and super. Then can we discuss about method overloading and overriding? I think that would be good. Method overloading and method overloading we can do. Yes, that would. Let me see. Quickly think about which way is the better. Okay, so let's discuss about method overloading and method overriding. I wish I need to finish these things faster. So, did you guys remember what are the object-oriented concepts? Object-oriented concepts are encapsulation, abstraction, inheritance, polymorphism. So, abstraction we achieved how? By writing a private variables, by writing all the variables and methods and providing the necessary details to the outside world. That is called abstraction. We achieve in the writing in a single class. And how can we achieve encapsulation? Encapsulation is nothing but keeping the properties and its behavior together in a single entity. Is called encapsulation. You can achieve encapsulation by defining private variables, public methods. So those private variables can be accessed through public methods outside the world. You cannot allow your variables to access by some other class directly. They always need to access through methods. That is called an encapsulation. Inheritance, we just discussed different type of inheritances that we have, right? So what is left? Polymorphism. What is polymorphism? You guys remember, right? TV remote. So same function behaving differently and different situations. That is called polymorphism. So, like I mentioned earlier, there are two types of polymorphisms. One is runtime polymorphism, another one is compile time polymorphism, another one is runtime polymorphism. So these are the two important concepts, okay, you may do in a day-to-day life as well, okay. So what are these runtime polymorphism? What is this compile time polymorphism? So simply remember, compile time polymorphism is nothing but method overloading. Just link the keywords, I mean just link the words, then you can understand later, okay. Did I mention anywhere here? Yeah. So compile time polymorphism can be achieved through overloading. How? What is overloading? I'll explain. Okay. Compile time. Remember, compile time polymorphism can be achieved through overloading. Runtime polymorphism can be achieved through overriding. Okay. What is this overloading and overriding? Is nothing but in the inheritance concept. What you will do? Let me show it to you simply. Overloading concept. So again, I'm taking class vehicle. In that void, I'm writing a method of method 1 inside vehicle. Okay, so I'm taking another class and just copy pasting just to save some time. Called car. Okay. Now what I'm doing here is public void method 2. Okay. Inside car. Oh, okay. Something I'll take bus here. Save bus. If you create same class name again, it will show an error within the same package. These are all just by keep practicing you learn. So here, sorry, not we don't need to. I just what I will do. Let's say extends vehicle. Okay. What is this concept? This is called inheritance. Okay. Nice. So what will happen is when now I got inheritance. So what I am trying to do is I create a bus object. Okay. Okay, I created a bus object. Now bu bus dot, if I ask method 2, that is something typical. if you create a class object, then you can access anything inside that class, right? So that is called it. So if I try to access bus dot method 1, this is possible because inheritance concept, right? Because of inheritance concept, you can access vehicles method 1 inside the bus object from bus object. So this is good. But what is interesting is, like, let's say I want to, if I give same name as my superclass method, and by following some rules, if you do this and if you create a bus object, now tell me which value will be executed. Whether, so same method 1, it is there, bus dot method 1. So whether this one will execute or this one will execute. I mean, what value will be displayed, inside bus or inside vehicle? Let's see. It is displayed as inside bus. It is displayed as inside bus because by looking at here itself, you can see whose object you are creating. By looking at that, you can say which method will be triggered. Even if it is extended, you can get to know at the compile time itself which method should be triggered. So that is the reason this is called compile time polymorphism. So what is the behavior? There are two behavior, inside vehicle and inside bus. These are the two different behaviors for the same method, right? Same method will behave differently. If you call vehicle object, then this method 1 will act as inside vehicle. If you call this bus object, then this method 1 will act as a inside bus. This is called polymorphism. But here, as it is happening between the classes, and you get to know at the compile time itself which one is going to be triggered before creating an object. So this is called a compile time polymorphism. And we can achieve through method overloading. So what are the rules for method overloading? We need to see. For method overloading, method name should be same. Okay, good. Argument types can be different. So which means, like, let's say int argument type should be different. Argument type must be different. Then only we can call it as method overloading. So let's say string. Okay, so in this case, look at now. So now I created a bus object. Nice. So bus can have method 1, right? But if you try to access bus dot method 1, pass 10 as an integer. Now which one will be triggered? Let's see. You can understand. Inside vehicle is triggered because you are passing integer argument. You are passing an integer argument here, so that it can distinguish. We can distinguish. Okay, this method is a string based argument. This method takes only strings. This method takes int. So as the user is passing integer, so this one will be triggered. Method 1, which is inside vehicle, will be triggered. But what if I try to bus dot method 1 text, this one will be triggered by this method is inside bus class. Did you got the difference? Did you understand the difference? Basically, at compile time itself, you get to know which method you are calling, even though with the method names are same. right? At compile time itself, you get to know. That is called compile time morphism, and you can achieve through method overloading. Method overloading is happens between the classes. Method overloading happens between the classes, and the method name should be same. Argument should be different. Argument should be different. And what else? What are the other rules? Method signature. Method signature is nothing but method name arguments. So it should be different. So if you look at here, method 1 string B, method 1 int A. The arguments has been different. So it satisfies the rule. And return type can be anything allowed. Return type is allowed anything. Like, even if you do here int, here void, like when you type int, right, you need to write some int value. You need to return some int value. Still they are overloaded. Still these two methods, method 1 in vehicle, method 1 in bus, are overloaded because the return type doesn't matter. All it matters is method name and the arguments. Okay. Then access modifiers, no restrictions. Throws, this is something we can understand later because this comes with exceptions. So for now, we need to understand is, let's say, what if I keep int A string B? Can they still be overloaded? Yes, they still overloaded. They still overloaded because all it matters is method name should be same and argument should be different. This is two arguments construct. This two arguments method. This is one argument method. Okay, so return type can be anything. It doesn't matter. It doesn't look, in order to say method is overloaded or not, it doesn't look at the return type. This is called method overloading. Make sense? Okay, so method overloading is nothing but compile time malwareism. What is method overriding? What is method overriding? What is method overriding? Method overriding is nothing but it happens within the class. You didn't know at compile time itself. You didn't know. Let's say, let's write another program simply. While writing program, discussing is good. Method overriding. Simple. We'll take a simple class. Train. Void method 1 void method 1. What it says, method name should be same. Okay, argument type should be same. Okay. 1 second, I'm just checking. I did a small mistake. Let me take it back. So first and foremost rule is in the constructor, in what you call overloading is happens within the class. Sorry for the confusion. I was just carried away. So first rule number is sorry. So let's go back to the first polymorphism. It's same method behaving differently at different situations, right? Depends on the situation. Okay, so what are the different types? There is one type, one is compile time, another one is runtime. So what is compile time? Compile time polymorphism is nothing but method overloading. Method overloading happens within the class. Within the class, remember, method overloading happens within the class. Overloading happens within the class. Overriding happens between the two classes with inheritance. Okay, so here, right, let's concept is same. We discussed everything correctly, but except thing is like method overloading or method overloading happens within the class. Okay, within the class if it happens. So if it is method one is within the same class, but the number of arguments are different. Argument should be different, like one should not, let's say method one should not having any arguments, and method one is second method one is having one argument, kind of like different combinations. Only thing is argument should not match either a type of either number of arguments, or type of arguments, or order of the arguments. Okay, so in this case, right, like even if you write like this, it's still int a. If you observe, the order has been changed. Here first int argument and then string argument, right? Second argument is string. Here string is the first argument, int is the second argument. So reverse. So this is overloading. So you can still distinguish which method will be triggered based on the inputs, right? That is called method overloading. And method overriding is method overriding happens between the classes. So in this, what is the rule? In this, what is the rule? Method name should be same, argument types also same, and method signature also same, and return type should be same. So it's like as is, whatever, if you write here public, let's say it is also should be public, or if you use private, it should be private. So if you use int a, you should be using int a here. I mean, any variable name can be have anything but int argument. Okay, so wait, inside method one of train, inside method one of engine. Okay, now return type is same, method name is same between the classes, and one more thing is you need to have inheritance concept between those two classes. Okay, this is called method overriding. This is called method overriding. So method overriding happens at runtime. You don't know, let's say now, right here, I will try to create a equal to new a. Sorry, we have a train, right? Let's say train t equal to new train. and t dot method 1 10. Let's see what will display for this guy. So I just created train object and then I called the method. Which method will be triggered? Inside method 1 of train. Okay, that is as expected because train doesn't know about engine, but engine knows about train. Remember that train doesn't know about engine because engine is extended train. Okay. So next one is here, like let's create an object called engine equal to engine e dot method 1. What will happen? So this one triggered engine inside method train, this one triggered engine. So let's try to create engine e1 equal to new train. Can you do that? You cannot hold train object with engine reference variable, but you can hold train reference variable. Variable can hold T1. See, this is not allowed. Subclass reference variable can't access superclass, can't hold superclass object, this one will be confusing, just focus. Okay, subclass reference variable can't hold the superclass object, but superclass reference variable can hold subclass object. So let's see now, if I call t1 dot method 10 here, right? Which one is C? Here I call t1 t dot method 10. Which one is triggered? It triggered inside method 1 train, method 1 of train. So same way I'm doing again. T1 dot method 1. Which one will be triggered here? Then third one it is going to display when I run. It will display inside method 1 of engine. Why? Because inside method 1 of engine, because it is holding the object of engine. This reference variable is train reference variable. Train superclass reference variable is holding subclass engine object. When it knows subclass engine object, it can access only subclass methods only, right? That is the reason, even though you have a reference to superclass reference variable, as you are accessing subclass and you don't know, right? It's the same lines. If you look at here, these two lines, that is what called runtime polymorphism. These two lines, these 4 lines is called runtime polymorphism. Try to understand. Okay, you created a train reference variable in both cases. You created train reference variables at both cases, but in the first case you assigned train object, but in second case you assigned engine object. So until and unless this object is created and assign it to it, and object is created and assign it to the reference variable, until then you don't know which method is going to be triggered, whether this method is going to be triggered or which this method is going to be triggered. So which means before creating an object, until you create an object, until and unless you are creating an object, you don't know, right? And object creation happens when? Not at compile time, it happens at runtime. That is the reason why it is called as runtime polymorphism. And runtime polymorphism can be achieved through method overriding. And in method overriding, there is one concept, interesting concept is called subclass reference variable cannot hold superclass reference object, superclass object. But superclass reference variable can hold subclass object. Okay, so let's say if I create another method, simple one method, only specific to train, method 2. I'm not overriding or overloading anything. I'm not doing anything. Okay, I'm just displaying, trying to see. Can I able to access from here? See, you can still how can it is able to access this guy? Because it is extended by train. So this behavior has been given to engine. So when you create an engine object, when you create an engine object, you can automatically get the superclass methods. So these are all the experiments you need to do. Make sense? Okay, nice. So go back and look these definitions once again quickly after this class so that you guys immediately remember. Okay, so tomorrow for sure I'll finish these things and I'll try to finish strings as well. With that, like, you know, we will be good shape, like, you know, all the basic concepts, then we'll go to different programs. Okay, good. Yeah. If anybody want recorded sessions, I started recording, so last couple of sessions, let me know. I'll try to upload as soon as I can and then I'll share it to you guys. Yep, that's it for today. And yesterday I supposed to send an assignment, but I didn't because I kind of thought like after today's session it would be good. So I'm just sending you guys now. Try to see those assignments and try to execute on your own. Practice. Okay, all I can say is practice. Okay, thank you.